A disk of radius 1 rolls all the way around the inside of a square with a side length s, where s is greater than 4. So basically a big square. So maybe our disk starts here, all right, and it rolls around, right, and it keeps going, and it sweeps out a region of area A. So let's just take it in a minute to figure out what this region looks like, okay? So as it travels rightward, right, it's going to, right, it's gonna sweep out this region. And then after that, it's gonna, right, keep going and sweep out this region. And then as it rolls along this side, it sweeps out this region, right? And then finally it sweeps out this region. So let's shade all of the regions quickly. So the first roll will cover this space. Then it rolls downward, covering this space, then this space, and this space. So as we draw a bigger diagram or a clearer diagram here, it kind of looks like something like this, okay? All right, and I'll also write the proportions here, okay? We know the disk has radius 1, so remember that this was the original disk, right? It has radius 1, so the distance here is just the diameter of the circle, which is 2. So it's a big region with that looks like this. We can calculate the area of this region, right? But let's take a look at the second disk first. We have a second disk of radius 1 rolling around the same square, right? So we start maybe here, and notice how when it's a bit different this time, right? Because we have this additional roll that covers this part, right? If you imagine fixing this point and rotating our circle 90 degrees this way, that will give us basically a big quarter circle here. Okay, and it has radius equal to the diameter of this disk of radius 1, so it's 2. All right, and it just goes around like this, so it kind of looks like something like this. All right, so this is the area 2, which is 2a, right? So let's take a look now. Let's say the side length is s, and we'll just calculate these in terms of s, right? The area of the internal region, right, is equal to, right, it's equal to, well, we can calculate it like so. First of all, let's look at these quarter circles. These each have radius 1, and they add up to, right, a total area of the area of a single disk, which is pi. Okay, and the rest are just like basically a big rectangular cross-ish region, right? We have that this length is 1, and so we have something like this. Well, this is the big square, so s squared, but minus the 4 corners here, right? So minus 4, each of these has a unit square, and then minus the additional internal square, which has length, right? S minus 4, right? Since it has area s minus side length s minus 4, because we're subtracting out 2 from both sides of the side length here, then we have to subtract out s minus 4 squared. This calculates to pi minus 4 plus 8s minus 16, or 8s, right, plus pi minus 20. All right, so that's the area of this region here. Now let's take a look at the outside region, which is basically here's S, right? And you see a bunch of these rectangular regions over here. And then 4 quarter circles, each with radius 2. So that gives us 4 pi. And then look at the rest, right? Each of these rectangles has side lengths 2 and s. So 4 of those, each with area of 2s. And that gives us a final area of, right, that gives us 4 pi plus 8s. And we know that this is, right, because area 2a. So we can say that this area is double this area. So we can write a new formula or equation here. 4 pi plus 8s equals twice 8s plus pi minus 20. Multiplying this out, this gives us 16s plus 2 pi minus 40, which means that 8s equals 4 pi minus 2 pi plus 40, or 2 pi plus 40, right? So then as a result, wait, it's sorry, 8s equals, yeah, so 2 pi plus 40. So then we're looking at a plus b pi over c. Well, s then becomes pi over 4 plus 5, or 5 plus 1 pi over 4, just to get it in the same format, right? The a is 5, b is 1, and c is 4, right? So a is 5, b equals 1, and c equals 4. So that gives us a plus b plus c is equal to 10, okay? And that is our answer. So there we go, it's 10.